Hi, I'm David. So for this problem, we're given an equation, x minus 6 squared plus y plus 3 squared equals 16. This is the standard form for a circle, with these two being the h and the k, which are the coordinates for the center of the circle, and this side is the radius. Technically, it's supposed to be 4 squared equaling 16, with the radius being 4, but they're just simplifying it and giving us 16. Anyways, what they're asking us to do is to find the x and the y intercepts. Now remember, the x intercepts occur when y is equal to 0, and vice versa. The y intercepts occur when x is equal to 0. So in order to solve this, let's do this one step at a time. Let's find the x-intercepts first. So we do that by setting y to 0. So we can just copy this down, but replace the y with a 0. So then that gives us x minus 6 squared plus 0 plus 3 squared. All of that is equal to 16, right? So then let's simplify this a bit more. 0 plus 3 is just 3. 3 squared is 9. So this becomes a 9. 16 is still there. We'll drop all of this down as well. So now to isolate the x, we want to move the 9 over. So we subtract 9 from both sides. This cancels that out. We're left with x minus 6 squared is equal to 16 minus 9 is going to be 7. And now we want to get rid of the square. So to get rid of the square, we have to square root both sides. Right? This cancels out the square. That gives us x minus 6 is equal to plus or minus the square root of 7. Remember, every time we square root something, we want to add the plus or minus symbol because it could be positive or it could be negative. And then last but not least, we just add 6 to both sides of the equation, leaving us with x is equal to 6 plus or minus the square root of 7. So this represents the x-intercepts, meaning one of the x-intercepts would be the positive version of this, and the other would be the negative version. So one would be 6 plus root 7, and the other one would be 6 minus root 7. Now let's do the same thing to find the y-intercepts. Like we said earlier, in order to find the y-intercepts, we have to set x to 0 now. So now we're going to do the same thing we did here, but just making the x a 0. So that becomes 0 minus 6 squared plus y plus 3 squared is equal to 16. We simplify this part. Negative 6 squared is going to give us 36. And then we can drop all of this down. This stays the same for now. Now we can subtract 36 from both sides. This cancels out, so then we're left with y plus 3 squared is equal to negative 20. And then in order to get rid of the square, we can square root both sides. This cancels out. We're left with y plus 3 is equal to plus or minus the square root of negative 20. Now remember, we're not allowed to have negatives inside of square roots. This is physically impossible unless you want to deal with imaginary numbers. So what this tells us is that there actually are no y-intercepts. There are no real numbers that could represent the y-intercept of this circle, right? Because what we received at the end is an imaginary number. Even if we wanted to simplify this and subtract the 3 over, it would be y equals plus or minus the square root of negative 20 minus 3, but still, we have an imaginary number here, and so that means we don't have any y-intercepts. So what does that mean? It means that this circle is off from the y-axis so that the edge of the circle doesn't actually touch the y-axis, which makes sense. Whereas here, the top of the circle actually does cross the x-intercepts, but at these 2 points, whereas it doesn't cross the the y-axis. And you can test it out on your graphing utility too, just so you can see that there is no y-intercept, but that there are two x-intercepts. And that is how you solve this problem.